probability trees always need each set of branches to add up to 1. The probability that Wendy wins the hoopla is 0.4, so the probability she loses would be 0.6. The probability that Wendy wins the coconut shy is 0.3, and the probability she loses, therefore, would be 0.7. And because the coconut shy is completely independent of the hoopla, they're completely separate things, it doesn't matter whether she's won or not won on the hoopla, the coconut shy will still have the same probability. Now the question says, use it to calculate the probability that Wendy does not win either game. So here, Wendy does not win either game. Well, here she wins one game and wins another. That's going down these branches, here and here. The next two branches is Wendy wins one and then loses one. So that's win and a lose. The third set of branches represent a loss and then a win. And the final set of branches represent a loss and then a loss. Two losses. So to work out the probability she does not win either game, I need to work out the probability at the end of this branch here. So I simply multiply the two probabilities. Every times we times. .42. And that's my answer. That's the probability that Wendy loses both games. Just note the bonus question here. It says, what's the probability that Wendy wins exactly one game? Now, if she was going to win exactly one game, looking at these outcomes in blue, these are the two for the bonus, and I'll put a little bonus star next to them. These are the two outcomes which would be needed to look at to work out this answer. So the probability she wins the first and then doesn't win, the top bonus star, would be 0.4 times by 0.7, which is 0.28. The probability that she doesn't win then does win would be 0.6 times 0.3, which is 0.18. And obviously with those two numbers I will add them up because I've got the top one or the bottom one. I need to consider both of these. So 8 add 8 is 16. 1 and 1 and 2 make 4, and 0 add 0 is 0. So the probability for the bonus question of winning one game, just one game, would be 0.46. Okay, very similar question that I've changed the numbers for. Just use this probability to work out the probability that Wendy wins both games, but start by completing the tree. Pause now before the answer appears. The first probabilities add to 1. The second probabilities add to 1. And the second probabilities are the same regardless of whether she won or didn't win on the first game. Now let's consider the outcomes. For this question, I want to know the probability that she wins both games. Always multiply the numbers to find the eventual probability at the end of the tree. And that's the end of this question.